Number one. I lost the number one here. Hopefully. Number one. We want to write our null hypothesis, alternative hypothesis for each one of these. For this first one, our HO, our HA. Can this be the HO? No, it's got to be the HA, so we put that down here as our HA. Also write, that's the original claim. HO is going to be the complement of that, or sort of the opposite of that. So instead of less than, it's going to be greater than or equal to 12. That's your answer for that first one. HO, HA, and make sure you tell which one's the claim. Number two, our HO and our HA. That's going to be your HO this time, so mu equals 5. That's the original claim. So you write that down. Your HA is the opposite of that, or the complement of that. So mu does not equal 5. That's all they want on that one. Now, as you're doing other problems with this first one, if we look right here, if it's a less than symbol, that means it's going to be left-tailed. Here, not equal to two-tailed. Number three, HO, HA. HO, HA. If it's got the equal to part with it, that's going to be our HO. So sigma is greater than or equal to 2.35. That's the original claim. Make sure you put that with each one. Our HA is just the opposite of that, so sigma is less than 2.35. That's our alternative hypothesis. Kim, which chart would I be using on this if we had to go farther on this problem? Since it's sigma, the chi chart. This one, we'd have to know what n is. This one, we'd have to know what n is before we could tell, but we'd be using the z or the t charts. Next one, a news outlet reports that the proportion of Americans who support plans to order deep cuts in executive compensation at companies that have received federal bailout funds is 62%. State the null, all that stuff. First thing you want to do probably on one of these problems is come out here somewhere and write down all the information. This time, since we're dealing with the percentage, that's going to be a P. So P equals 0.62. Make sure you read it carefully. It says is 62%, so that means equals. If it said is more than or is less than, then it'd have to be one of the other symbols. We'd have to decide that. So P is 62. State the null. So all we're going to do on this one is state the null and stuff, so we really don't need all that. State the null and alternative hypothesis. Well, our null hypothesis is going to be P equals 0.62. That was the original claim. Alternative hypothesis. The opposite of that, which is P does not equal 0.62. The type 1, type 2 errors. Type 1 error. Remember, the type 1 error is where you reject the null hypothesis and it ends up being true. So here, for a type 1 error, we reject 62%, and then it is true. So we reject their claim, and their claim ends up being true. Type 2 error, anybody remember what a type 2 error was? We didn't do a whole lot
Fail
with
to
yours.
reject and it's still true.
All right, so we fail to reject 62%. And then it is false. Determine whether the hypothesis is left-tailed, right-tailed, or two-tailed. You look at your alternative hypothesis, if it's got not equal to, and you might want to write that down somewhere. Remember, that's right-tailed. No, it's not. That's left-tailed. That's right-tailed. That's two-tailed. So what is this one? Two-tailed. Next one, number 3, questions 5 through 7. And this is nice of me here, Kim, because what table are you going to use? The Z table. So we're going to use the Z table to find this. So get out your Z table. On your Z table, I'm going to write this up here real quick. You might want to write it down. Well, maybe I'm not because it takes too long. You might want to write that little chart for the alpha 10%, 5%, 1%, left, right, 2. So that way you don't have to look all this up every time. You can get it right there off that little chart. It's in your book somewhere. We wrote it down in the notes a couple of times. Right-tailed test, alpha is 0.01. Well, I'm looking at my little thing right here and it says 0.01 right-tailed, and it's going to tell me the critical value. So my critical value this time, my Z sub 0, is just Z sub 0 equals 2.33. Is that not right? Use this little chart right here that we wrote down a bunch of times. And it says alpha 0.01, left, right, and two-tailed. And it says on my right tail that it's 2.33, unless I wrote it down wrong. Let's jump down to number 7. Number 7, two-tailed. And we're at 0.05. So 0.05. We're at two-tailed. We're going to have 2 critical values. Remember, it's going to look like this. You're going to have a critical value here, a critical value here, because you're two-tailed. So you should have 2 answers. Well, on 0.05 for two-tailed, it's got, on my little chart right here, it's got plus or minus 1.96. So my Z score is 1.96, and then my other Z score is negative 1.96. You could just put plus or minus in there instead of writing it twice. Now this one, this is the harder one. Number 6 is the harder one because you actually have to use the chart. Remember, this is your area. So we got to find, we're left-tailed. We got to find, if we're left-tailed, that means we're on this side. So it's going to look like this. So all we're looking for is this area. So we're saying that area is right there. If we were right-tailed, if it was over here on this side, we'd have to subtract from 1 and find the area here on the chart because that's the way the chart works. But we're going to find the area of 0.08. So you look down through the chart and you find whatever's closest to 0.08. And it looks like, what's the closest? 0.0793. Is that the closest? So that's negative 1.41. So our Z sub 0 is negative 1.41. So if it's one of these that's on this little chart, and some of you are going, wait, what? It's because we wrote it down like 4 times and you didn't bother to write it down. That's your own fault. So get it out of the book. Next one, number 8. The U.S. Department of Agriculture claims that the mean cost of raising a child, and I'm going to do this as I go down through here. So the mean cost, we need that. So that's our mu. Mu equals, of course he's got to be great big huge number, so I don't have much space here. 10,380. So that's our mu. Random sample of 500 children, so n equals 500. Age 2 doesn't really make any difference. And we figure out that our x bar, that's our sample mean, is 10,240. So we're saying when we did a sample, it cost $10,240 to raise a kid for those first 2 years, and the Department of Agriculture said it cost about $10,380. And then our alpha is, our level of significance is 1%. So we're going to check this at a 1%. Remember, the lower the percent here, the less likely you are to reject something. So we're giving them the best chance to be correct. State the null and alternative hypothesis and identify which one's the claim. So our HO, somebody have those written down. Make sure you got those written down because I'm going to need them on the next slide and I'm not going to have them. Our HO this time is just this because it was equal to. So HO is mu equals 10,380. What's the HA then? What's the alternative hypothesis? Mu does not equal 10,380. Before I go any far, we need to tell this one was the claim. That's the original claim, so we make sure we have that. And I always, again on this first part, I always tell if it's left-tailed, right-tailed, or two-tailed. This one is two-tailed. You don't have, that's not part of your answer for your test. It's just to help you with the rest of the stuff on down through here. Part B, you find the critical values. We're going to draw this graph. Well, our graph's going to look something like this since it's two-tailed. This is going to be shaded. You're going to get a point on the test for drawing this graph and then writing in those numbers there. You know, it's two-tailed, so it's going to look like that. And we got to find those two things. So we got to go to our chart. It's a Z. We're on the Z chart because we're dealing with mu, and we want to find, we're at a 0.01 level significance, and we're two-tailed. So I'm looking right here, 0.01 two-tailed. And that says plus or minus 2.575, right? So it's Z sub 0 is plus or minus 2.575. So what's this critical value going to be right here on this side? Negative 2.575. What's this one going to be? 2.575. 2 points for that, point for that. Making sense so far, Wade? Next part of this one, I couldn't fit all this on one slide. Oops, went the wrong direction. Find the standardized Z-score. This is where we got to use the formula. Formula for our Z-score is X bar minus mu over standard deviation divided by the square root of n. Somebody help me out because my scores are gone. What was our X bar?
10,240.
Minus, what was it, 10,380? Over, what was our standard deviation? And this right here, even though it's sigma, it could also be S. Doesn't matter which one it is.
1561.
I forgot to write that down over there, didn't I? And then what was our N?
500.
Somebody figure all that out for us. Jonathan's gonna help us out here in a minute, cause I can't see my graph anymore, so
Negative
he's gonna be able to tell me where it falls.
2.01.
Negative 2.01, everybody agree with that? Yes, no, maybe? Negative 2.01 on our graph. Next thing we look at, we don't really need this, but I don't have mine up here. Does that fall in this, or does that fall in one of the rejection regions?
Circle.
Falls in the middle there. So what's that tell us to do? Fail to reject. Fail to reject. We fail to reject that because it fell in that middle region. Negative 2.01 fell in here on your graph that I don't have up here anymore.
Okay, how do you put that in a calculator? Cause I'm like doing it weird.
Put this in. Put the top part in. Hit equals.
Okay, that's,
Hit equals. You ready?
yeah.
Then hit divided by. Then you hit a parenthesis. 1561 divided by second square root 500. Then you, when you get done, you're going to have to hit parenthesis, parenthesis. Did it give you that?
Yeah.
So you got to be on this one. You got to put that double parenthesis in because of the square root at the end. Or that's the way I do it. I mean, there's probably 1,000 other ways to do it. We want to interpret this. If we fail to reject, need all this on one slide. So we're failing to reject the null. What's that telling us about the Department of Ag's claim? What do we know about their claim then? That's right. That we're failing to reject it, so we're saying there's not enough evidence to prove that their claim's wrong. So, what was our alpha? 1%. So at 1% significance, if you can't read my writing, you better be listening closely. Level, there is not enough evidence to reject Department Ag's claim. So there's not enough evidence to reject the fact that it costs $10,380 to raise a kid for the first 2 years. Next one, questions 9 through 11. T-table, so get out your T-table. On the T-table, we have a right-tailed test. Our alpha is 10% or 0.10, and our N is 11. First thing you gotta do on this one, find your degrees of freedom. What is our degrees of freedom in this case? 10. All right, remember it's your N minus 1, so that's your degrees of freedom is 10. You're going to use that degrees of freedom, this, and the fact that it's right-tailed. Look it up on the chart. Actually, on the chart, you don't need the right-tailed, you just need the fact that it's one-tailed. So we go down to 10. Somebody's going to have to help me out here because I can't see my paper.
1.372.
So our T sub 0 is 1.372. Now what else you have to remember, if it's right-tailed, that's on this side, is that going to be a positive or a negative? Positive. So if it's right-tailed, it's a positive. If this had said left-tailed, then we'd be over here and we'd have to make it a negative. So on this next one it says left-tailed 5%, t-shirt. DF is 5 minus 1, which is 4, so we use that. Remember the t-chart's for very small samples. 4.05.
Negative 2.132.
Everybody agree with that? Again, I can't see it. Negative 2 point what?
132.
132. That's a negative because it's on the left side, so it's there. Two-tailed. Usually with two-tailed, we have to worry about splitting it up and taking half on this tail, half on this tail. Well, the T-chart's set up so that you don't have to do that. It gives you, it already splits it up for you. What's our DF this time, our degrees of freedom? 25. How come the degrees of freedom only goes up to 29?
30. Because you can.
30. 30 is a large sample, so we'd use the Z-chart instead of the T-chart. So 25 at 0.01. Two-tailed, make sure you're on the two-tailed. What's that tell us?
2.787.
2.787. Now is our answer going to be just 2.787?
Plus minus.
All right, since it's two-tailed, we got to do the positive and the negative, 2.787. Next one, a fitness magazine advertises that the mean monthly cost of joining a health club is $25. You work for a consumer advocacy group and are asked to test this claim. You find that a random sample of 20 clubs cost 26.25 or have a mean of 26.25 and a standard deviation of 3.23. You want to do it at a 10% level of significance. I'm going to write all that down here. This is our mu this time. Mu is 25, N is 20, our X bar is, and my pen's a little off so I hope you can read all this, 26.25, and our standard deviation this time, our S is 3.23. And our alpha this time is 0.10, 10%. We're going to state the null hypothesis and the alternative hypothesis. Which one's going to be the null this time? That's that claim, right? Because it's got the equal to with it. So mu is 25, that's the original claim. That's their claim. Make sure you mark it. Which one is the original claim? What's the alternative hypothesis going to be then? No, it does not equal 25. We get out the T-table again. Our DF. This time we had 20, so our DF is 20 minus 1, which is 19. And our alpha is 0.10. Oh, the thing I forgot up here. So it's left-tailed, right-tailed, or two-tailed? This is two-tailed. We're going to have to use that along with this on our chart to find our T-score, or our critical value of T. Actually, there's going to be two of them, so it's going to be plus or minus because we're two-tailed. So we go to 19 on our table, over to 0.1, two-tailed. What do we have? 1729, is that right?
Yes.
We draw our little graph over here. Horrible graph. Draw yours better than mine. Shade this, shade this. This is negative 1.729. This is positive 1.729. getting bored doing the same thing over and over and over again? It's the same stuff over and over and over again, isn't it? Are you learning it though? Is it going in there? It's not coming out the other side and going to Miranda, is it?
No.
All right. Don't want to share nothing with her. Jonathan's not sharing any of his great knowledge. Next, we want to use the formula. What's the formula for T? Same thing, right? X bar minus mu over S square root of n. Somebody help me out because I don't have the numbers up here again. What was our X bar?
26.25.
26.25 minus, what's our mu?
25.
Standard deviation.
3.23.
And what was it, 20 that we had in our sample?
Yes.
Somebody figure that out for us. Is everybody scared?
1.73.
1.73. Look back at your little graph that you had on the other one. Where does 1.73 fall? Does it fall here? Probably not. Does it fall here? Does it fall here? If it falls there, what's that tell us?
Reject.
We reject the null. Now, what's rejecting the null tell us on this one?
Enough evidence.
At a 10% level of significance. And notice when I'm writing significance, I sort of skip some letters because I'm not sure how to spell it. 10% level, but you can't tell because it's so scribbly. 10% level significance. There is enough evidence to reject the claim, that the mean is $25. So we don't believe them anymore that the actual mean is $25 of the health clubs in that area. Same kind of problem here, except this time we're dealing with percentages. So instead of mu and all that stuff, we're going to have p. This time our p, sorry, that's wrong. Here's where you got to be careful. It says the reports that over 20%, so our p is greater than 0.20. Man, that's horrible. P is greater than 0.20. Jonathan, don't write down my scribbles. Now on this one's a little tougher because you're going to have to do something on this one. To find your p hat, on this one you've got to actually divide. So your p hat is 256 out of your 1420. So somebody grab their calculator. What's 256 divided by 1420?
1.80.
That didn't sound right.
0.180.
0.180, so 0.18. So that's our p hat. Is 18%. So here they gave us how many people actually said that they agree with it out of how many, and we find that. What else do they tell us here? Alpha's 0.02. A little tougher when alpha's 0.02 on this one because we actually have to use the chart to look it up instead of knowing it. And our N this time, we used right here, our N, people in the survey was 1,420. our null hypothesis and our alternative hypothesis. Can this be the null hypothesis this time? No, because it doesn't have the equal to, so that's got to be the alternative hypothesis. P is greater than 0.20, that's the original claim. Make sure you label the original claim. What's your null hypothesis going to be then?
Less than equal to.
So now you got to be careful when we go back and we decide we reject or fail to reject or whatever. We got to remember that the claim was actually not the thing that we're rejecting or fail to reject. It's actually the alternative hypothesis. Find the critical values on the Z table, and we're going to draw our little chart again. So we're going to have our little chart out here. Is this going to be one-tailed or two-tailed? One-tailed, and it's a right tail because it's greater than there, so it's going to be something over here, and this is going to be shaded. We're going to have to find that number. We use our Z table this time. Now on our Z table this time, since our alpha is not one of these numbers, 0.10, 0.05, or 0.01, and we're right tailed, what we have to do is we have to take 1 minus alpha. Well, what is 1 minus 0.02? 0.98, is that what you said?
Yeah.
You did the same thing that I do a lot of times. We subtracted like that was a hole right there instead. So 0.98, so what we look up on the chart is we want, and it's going to be on the positive side, we want the Z value where this area here is 0.98. So we look down through there and we figure out what's closest to 0.9800 on the chart. Let's see. Got 0.9803, but if you go back 1.9798, 0.9798 on the chart, that's probably the closest, right? What's that? 2.05, is that right?
Yeah.
So our critical value of Z is 2.05. Didn't we have that earlier? So you put 2.05 right there. So you're just using the chart. You're finding this on the chart. This is your area, but you're using the chart backwards. Somebody make sure you got this down, because I won't have the chart on the next slide and I won't have our numbers. Find the standardized test, the Z-score. So now we're going to do Z equals, our Z is X bar minus mu over S, or sigma square root of N. This actually should be, if I wanted to be mathematically correct, since we have a big sample, it should be sigma, not S, but it doesn't matter. It's going to be the same thing regardless. What was X bar? I'm sorry, that's not right, is it? You guys should have stopped me before I did all that. P hat minus P, I forgot we were dealing with percentages. P hat minus P, different formula. P times Q over N. Got to remember which one I'm doing. What was P hat this time? 0.18. P was 0.20. Down here at the bottom, P is 0.20. Now your Q, how do you find your Q?
1 minus P.
So Q equals 1 minus P. Well, 1 minus 0.20 is 0.80 over, what was our N? What was it? 1420. Plug all that into the calculator.
Pardon me, teachers, for the interruption. At this time, I need all our club members going on the field trip to meet in the high school commons, please. Thank you.
Plug that into your calculator. When you plug this one in, what I usually do, I plug in the top, hit equals, divided by, then it'll do, hit square root, and put all that in, and it'll just do one parenthesis this time. You don't have to do the double parenthesis. What's that come out to be?
I got an unreal answer.
Negative 1.89.
Negative 1.89. I got negative 1.88, but I might have rounded wrong. Now we look back at our thing, our graph here, and it was like this. What was this number again? 2.05? Where's that gonna fall? That's gonna be way over here somewhere, right? So what's that tell us to do? Fail to reject. Fail to reject. Now, here's where you gotta be careful. It's fail to reject. But if we're failing to reject this, what's that tell us about the original claim?
It's true.
Because it wasn't the null, we're failing to reject the null hypothesis. So we're saying this is true. What are we saying about the original claim?
False.
That's false. So, what was our alpha?
2%.
So at 2% level of significance, there is not enough evidence to support the claim that 20%, what was it? 20% don't have health care. That 20% don't have health care. Next one, get out the chi chart. Your chi chart.
Do you have any activity?
On the chi chart, Wade just stole my chi chart, so I'm not going to have one. On my chi chart, first thing you need to do, find your DF again. 13 this time. We're at a 0.01, 13, we're right-tailed. On the chi chart, what's that tell us? First, right-tailed. On the chi chart, everything's going to be positive. If you're right-tailed, do you have to do anything special? No, right-tailed is just normal. If you're left-tailed, like on this one, that's where we got to subtract, right?
Yeah, 1 minus the alpha.
1 minus alpha. We have to do 1 minus alpha on left-tailed. Two-tailed, we got to do half times alpha and 1 minus half times alpha. What do you come up with for this one? 27.688. So if we were right-tailed, it would look like this. That's a terrible drawing. It would be that way. Remember, for your chi too, your drawing should be more like this. It's got like a swoop on that side of it. So that should be more like what your drawing should be. Left-tailed, we got to do 1 minus alpha. Or well, first let's do our DF. What's our DF this time? Our 6. Our 1 minus alpha, what's 1 minus 0.05? .95. Now we use those two and we look it up on the chart. And that's gonna give us our chi-squared sub-zero. Remember, your sub-zero is always your critical values. What's it come up with on the chart?
1.635.
635?
Yes.
Everybody agree with that? Yes, no, maybe? Two-tailed. What's our DF this time? 80? This time we actually have to use 80 and half of alpha. What's half of 0.10? 0.05. So that's going to tell us one of our critical values. And then we got to do 1 minus that 0.05 and 80. What is 1 minus 0.05? 0.95. So this time we're actually going to have two chi-squared sub-zeros. That's squarable chi. Now, when Michael's at home watching all those cartoons that got chi in them, chi this and chi that, all these cartoons from Japan, he'll know that, you know what, chi's a math thing. It's not, why do they stick it in, why is this guy's name Chi something? So his name is Chi X something. That's stupid. What is, for this one, you look at that up on your chart, 80 and 0.05, what do you come up with?
101.879.
879?
Yes.
That would be our upper limit, our right side limit. What's our other one?
60.391.
Those are two. So on that one, remember it would look something like this. You have one there, one there. These would be your rejection regions. You don't need the charts on these, it didn't tell you to draw them. Last one. Bolt manufacturer makes a type of bolt to be used in airtight containers. Manufacturer needs to be sure that all of its bolts are very similar in width. So it sets an upper limit for the variance. So the variance, how much it changes, can't be very much. And if it changes 1%, that's probably way too much. I don't know of any company that would set their variance at 0.01. That seems like an awful lot of change. A random sample of 14 bolts has a variance of 0.064, and at alpha at 0.5%, is there enough evidence to reject the manufacturer's claim? We need to come over here and write all this out. Let's see, their variance, so that's sigma squared, is 0.01. We did in a sample of 14 bolts. And our variance, so our S squared, came out to be 0.064 right away as I'm writing down some of these numbers. If our variance came out to be 0.06 and their variance is 0.01, what do we notice?
Somebody screwed up.
Yeah, somebody's messing up pretty bad because that's an awful lot way out of range what it should be. It's 6 times as much as what they're claiming. Our alpha is 0.005, so we're doing a real small level of significance here, trying to give these workers on this assembly line or whatever as much benefit of the doubt as we possibly can. Did I write down everything? Didn't miss anything this time. We state our null and our alternative hypothesis. Which one's going to be our null hypothesis this time? And that's the original claim. Make sure you tell that that's the original claim. What's our alternative hypothesis this time?
Not equal to.
Not equal to. What's that tell us about this?
Two-tailed.
Finally remember to do it. very last one. Now we gotta find the critical values. We're gonna find those critical values by using that chi table, just like we did on the previous 3 problems. So what do we need first?
Use that 13.
D of F is 13 this time. We know it's 2-tailed, so this time we're actually gonna have to do our 13 and half of alpha. Well, what's half of alpha? Take your calculator and do it for me.
0.0025.
That's gonna give us one of the tails. Then we're gonna take 13 and 1 minus, so we want half alpha. And then we want 1 minus half alpha. To get these numbers, that's half alpha. Then 1 minus half alpha, we're gonna put right there. What is 1 minus that?
0.9975.
Now we're gonna find our 2 chi values, or chi squared values, by using the chart. What's that one give us? 13 and 0.0025. 4.736. And what's this one give us? Look for
8.565.
8.565?
3.565.
3.565. Draw your little graph. And that's a horrible looking chi graph. We're here, shaded region, what's this number gonna be? 3.565. What's this number gonna be?
24.736.
So if in one of those two, we're gonna reject the null. If it's in this middle part here, we're gonna fail to reject. Next thing we gotta do is find our actual chi value. Find the chi value. This is the formula. N minus 1 times S squared divided by sigma squared. Somebody help me out. What was it in this time? 14 minus 1. What was the standard deviation of our sample? Or I'm sorry, what was the variance of our sample?
0.064.
Over what was their standard, or their variance? 0.01. This one's a little easier to punch in the calculator, it's pretty straightforward. 13 times that, it equals divided by 0.01, what's that give you?
5.32.
5.32, is that right?
Yeah, I got 83.
Joe, you tell me the wrong answer one more time. Joe, you wanna know what you did wrong, I bet? When you got to here, hit, on this top part, hit equals, then divide by that. Because otherwise, sometimes the calculator doesn't understand and it divides this, and then goes back and does multiplication or some other way. It actually uses PEMDAS. So make sure, so 83.2, look at your thing that we just did. Is that gonna fall here, here, or here? Left, right, or middle? Right? So it's gonna be over here. So what's that tell us to do? So we reject the null. Well, if we reject the null, what was the null again? Was that, the null was their claim of 0.01, right? So we're gonna say at 1/2% level of significance, claim that the variance is 0.01 for the bolts. Spelled bolts wrong. What's that tell us? Are you, if you have a job where you're actually doing this for those bolts, are you really gonna go in and say, hey boss, we're rejecting your claim that, no, what are you gonna have to, what's that telling you you're gonna have to do at that factory or at that shop or whatever?
Somebody's getting fired.
Yeah, maybe not. You gotta go back and recalibrate your machine, fix your machine so that it's doing something right, okay? Because for some reason, our bolts are coming out way off and you're gonna send them out to the people that buy them off of you, and then what are they gonna do? Your bolts are crap. They're gonna send them back to you and they're gonna go to a different company. Everybody got all that before I shut this down?
Don't discard it. You wanna keep it.
No, I don't. This is what I want.